Okay, let's start. Hans Verlinde, State of Statelessness.
Good morning. It's great to be here. So my name is Hannes. I am an iOS developer at Facebook in London. And today I would like to talk about things that change, things that don't change. And to start, I would like to take us back to the 2nd of June of 2014. To many people, this was a day of change. Here's a typical tweet from that day. So I think it's safe to say that Swift changed at least something. To me personally, what I found most interesting was how it made functional programming cool again. I mean, before Swift, we had things like reactive Cocoa, but those were never really mainstream. Today, everyone seems to be talking about map, reduce, filter. If you go to an iOS conference today, you might find sessions on Haskell, monads even. It's pretty cool. Now, you have to know that 10 years ago, I was a Haskell programmer. I did nothing but Haskell every day, all day. And then eventually, I decided to grow up, get a real job, use a real programming language. And now it's all back, so it's pretty cool. But it also makes you realize that nothing new is really new. And I think if you go to see Graham Lee's talk this afternoon, I'm pretty sure he would agree with this. So the same ideas seem to keep coming back. And the reason they keep coming back might be that, as we all know, there are no silver bullets, right? Some complexity cannot be abstracted away. On the other hand, a lot of complexity can be abstracted away, and it can make a big difference. If that wasn't the case, we might still be programming in assembler or something. I'm pretty sure if you were ever programming in assembler and you started using higher level programming languages, it sure felt like a silver bullet, right? So we need these meaningful abstractions. It's the only thing we have to manage complexity. But the question is, which abstractions are meaningful? Which frameworks are just hypes, and which ones are almost silver bullets, or have the potential to be it? You don't want to be left behind when the next big thing really arrives, but you also don't want to jump on every new framework or technology, because there's always a price to pay. Even if you have a meaningful abstraction, there might still be a learning curve or maybe a performance penalty. Maybe the abstraction starts leaking in some of the edge cases. There's always a price to pay. So how do you decide this? Well, turns out this is hard for everyone. And the answer very much depends on your specific context. I love to read the Swift diaries that Brent Simmons wrote, because there you see how even a very experienced developer, iOS developer, is struggling with something like this. Should I use Swift or not? And one day he's like, oh yeah, this is going to be so much fun. I'm going to learn a new language. And then a few days later, it's like, this is just too hard. I could do this so much faster in Objective-C. Maybe I should go back to Objective-C. And of course, we've had some of this going back and forth at Facebook as well. After all, at some point, we had a native app. And then we decided to throw it all away and go for an HTML app. It seemed like a meaningful abstraction at the time. Abstract away all the platform-dependent details. Share code across platforms. Seemed like a great idea. But it turned out the price we paid for that was too high, mostly performance issues. So we went back to native. At that point, we started using core data. Looked like a very meaningful abstraction, and it is. We even benchmarked it to make sure it would perform well. But as we kept on growing our client-side data model, eventually we started hitting some performance issues that we couldn't really work around anymore. And we started struggling with all these mutable models everywhere. So eventually we got rid of all of our core data stack. These are expensive decisions. It doesn't mean core data is bad, of course. It just means it didn't work out for us specifically. So I don't think you can avoid making these decisions. And you probably cannot even avoid making some wrong decisions and paying the price occasionally. What you can do is try to focus on IDs rather than frameworks, the IDs behind those frameworks. Especially those common IDs, those common patterns that seem to keep coming back. When you have different movements in software development and they all seem to come to the same conclusion, then you might be onto something. I don't listen to everything Apple says, but when I hear an engineer at WWDC say something, and it's the same thing I heard in functional programming 10 years ago, and it's the same thing that experienced developers at Facebook are telling me, then I start paying attention. And of course, you want to focus on why these IDs are valuable, not just the IDs themselves. And I think you'll find that most of the time, what it's really about is about making it easier to reason about your code. Because if you think about it, that's the real scaling issue that we all have. It doesn't matter what you're working on. You want to keep it manageable to reason about your code. So I will be discussing some frameworks today, but I also want to focus on the ideas behind those frameworks. And one of these big ideas from functional programming is that to avoid or to manage complexity, you should avoid state. That's what functional programming is really about. Declarative is better than imperative. In functional programming, you have a map. In functional declarative programming, you have a map. In imperative programming, you have a for each. And we'll look today at how this idea applies to user interfaces. But you could tell a very similar story for the model layer, maybe even the network layer. We will focus on UI today. So declarative user interfaces means you focus on what rather than how. You tell the system what you want and you let the system figure out how to do it. Now, if you think about it, this is very much the idea behind auto layout and interface builder. As a developer, you specify high-level constraints and you let the framework figure out where each view should be exactly, how big it should be. So Apple has been promoting this for many years. This is not a new idea. They did not introduce this with Swift in any way. We did consider using auto layout at Facebook. It also didn't really work out for us specifically. There's a few reasons. It's pretty hard to set it up in code. It's a lot easier if you use interface builder, but if you have a code base of a certain size, if you have a number of developers working on it, using interface builder is not really an option because you cannot merge those files, right? So it's just in practice, it's very hard. You run into issues with it. It can also be hard to debug. If something goes wrong, it can take a while to figure out why. And when we benchmarked it, it didn't perform that well on the very complex hierarchies that we have in our newsfeed, because it mostly runs on the main thread, right? But yeah, again, this is a very much context-dependent answer. Maybe if you have a smaller team, if you have less complex view hierarchies, auto layout may be perfect for you. It all depends on your context. Now, what do we say when we mean you should avoid state in your UI, or you should avoid stateful UI? After all, if you have an app with some kind of newsfeed and there are stories in there and you can like those stories, then a story is going to have a like count. And this like count is going to change over time. That's state. And your UI should reflect that state. There's no way to avoid that. So what exactly do we mean? Well, we mean that ideally, your UI should be a pure function of the state. And your UI should not need to consider any state transitions. The transitions should be covered by whatever framework you're using. And to illustrate this, here you have a little bit of UI from the Facebook app. So there might be a like button and a comment button and a label that tells you how many likes and comments there are. And if you like this specific story, then the like button should be blue, otherwise it should be gray. So in this case, there might be something like 8 different states. Now, it should be clear that it's much easier to reason about what the UI should be for each state than to reason about all the possible transitions from one state to another. Because if there are n states, there can be n squared transitions. It's easier to reason about states than transitions. That's the main idea. Now, when we say UI is a pure render function, we mean it in a mathematical sense, right? So you have state as input, you have UI rendering as output. There are no side effects. It doesn't matter how many times you call this function. You always get the same result, same input, same output. That's functional programming. A related idea is the concept of a one-way data flow. So this tells you that ideally, data should flow typically from the model layer to the UI layer, but it should flow in a single direction. And again, this is a good idea because it makes it easier to reason about your code. It's very hard to reason about code if data and events are flowing all over the place. So at one point, the data flow in part of our app might have looked like this. So there would be a model store, and it would send the model to the view controller, and there would be a hierarchy of view controllers, and each view controller would configure its view. And then at some point, you would tap a like button somewhere, and then the like view would update, or would notify the like controller, which would update the model, send it back to the model store. But it also needs to notify the parent view controller because the height of the view might change. So basically, data was flowing everywhere. Today, it looks much more like this. So you still have data flowing from the model layer to the UI layer, but it doesn't really flow back. So what happens when you tap this like button? Well, it's not the like controller that's going to update the model. Instead, it's going to go back all the way to the model store, maybe even further. Maybe there's some dispatcher in front of it that will update the model. And when it updates the model, it will reflow the entire UI from there. So you get this kind of single directional circular flow, which is very different from anything you would get with key value observing or two-way data binding. There, data is flowing in both directions. Here we have a singular directional flow. Now, this is an idea that's also being promoted by Apple. If you look at last year's WWDC, there was a session on advanced iOS application architecture and patterns. You will find some very similar slides there. A lot of errors at first, fewer single directional errors in the end. Another related idea is the concept of immutability. This is related because it helps to enforce a one-way data flow. If you don't allow to update a model, then you're basically forced to create a new one, and it's much more likely to start at the same origin, to start in the model store again and reflow from there. Of course, the other great thing about immutability is that it's thread safe by design. If you do not allow to modify an object, then you don't need to worry about different threads modifying that object at the same time. Managing concurrency is still a big challenge today, and the reason is it doesn't really scale well, and there's only a limited set of options you have. Option one is you do everything on the main thread. It doesn't scale well because of performance, obviously. Option two is you make every property atomic. It also doesn't scale well. Even if every single property is atomic, you will still get race conditions depending on the exact order the setters are called in. Option three is you do things properly. You use the stuff they teach you in college. Things like shared locks, semaphores, all that stuff. Stuff you really want to forget about after college. It also doesn't really scale. In a way, it's just too hard. As your code base grows, sooner or later, you're going to run into bugs. And they're going to be ugly bugs, deadlocks, that kind of stuff. So if none of these options scale, we need to cheat. And we cheat by immutability. We don't allow to modify objects, and suddenly everything becomes a lot easier to reason about. We tie our hands to free our mind. That's immutability. And of course, this too is promoted by Apple. If you look at Swift, there's a lot of focus on value types, constants. Next is composition. Composition is great because if your UI components are truly composable, it gives you an alternative to subclassing. And subclassing is typically bad. I would even say if I'm reviewing code today and I see a class being subclassed, I would almost consider it a code smell, which is very different from where I was a few years ago. But again, it's about how hard it is to reason about your code. If you have a hierarchy of subclasses, it becomes very hard to reason about where a specific behavior is implemented. It might be anywhere in the chain. Consider what happens if you modify a method in the base class. It might affect a subclass, but maybe the subclass overrides that method and it doesn't affect it at all. Maybe there's some other class in the chain that overrides that method. It's very hard to reason about. And of course, this too is an idea that's currently being promoted by Apple. If you look at the session on protocol-oriented programming this year's WWDC, they state this very clearly: avoid inheritance, prefer composition. So these are some ideas. Now I want to talk about frameworks a bit, because we do have a few frameworks at Facebook. And I think it makes sense, right? I mean, the bigger your code base, the more developers you have working on it, the more sense it makes, the more it pays off to invest in stable infrastructure to support meaningful abstractions. So the first framework I want to talk about is React, because the ideas we discussed here are really the main ideas behind React. React is a web framework, so it's a JavaScript library for building user interfaces on the web. And the core abstraction of React is the virtual DOM. So instead of programming any DOM changes manually, you build React components, which are like specifications of the UI, what you want it to look like. And these components have pure render functions. They map state to virtual DOM elements. And there's a one-way data flow. So conceptually, whenever something changes, you reflow your entire UI. This is very simple to reason about. It's about state, not transitions. But the performance is also good because the library runs a view diffing algorithm. So even though conceptually you reflow your entire UI, the library will detect what actually changed. And it will apply those changes to the actual DOM, but you don't need to worry about that. You reason about state, not transitions. Now, I'm not a web developer. I do know there are a lot of JavaScript frameworks out there. I would still argue that React is something special. We released this as open source in 2013. The response by the JavaScript community has just been huge. I mean, this thing has like 28,000 stars on GitHub. A few months ago, I was in Paris to attend the React Europe conference. There were like 700 people there. It's crazy. And it's not just React itself. If you look at other JavaScript frameworks today, you will see that a lot of them are heavily influenced by React. So this really changed something. It changed something at Facebook as well. It changed the way we develop for the web. But the ideas behind React are not specific to the web. So it makes sense that at some point we try to apply those to iOS development as well. This led to ComponentKit. We released this as open source about a year ago. So this is a framework for iOS which is heavily React inspired. It's also based on pure render functions. It has a view diffing algorithm. So conceptually, you reflow your UI when something changes, but the framework will detect what has actually changed, and it will apply those changes to your UI views. Today, ComponentKit powers a big part of our main Facebook app. It powers all of Newsfeed. So this is really important for our code base today. I don't want to delve into code too much today. I think there are some very good tutorials out there, but just to give you some idea of what it looks like, here you have an article component. So this takes an article model as input, and it renders this as 3 subcomponents. And it's a stack of subcomponents. There's a header component, a message component, a footer component. And it's a vertical stack of those subcomponents. So basically, instead of views, you have components. And components are like descriptions of views, specifications, stencils. They specify what, not how. And the CK stack layout that's being used here, that's an implementation of Flexbox, which is a CSS standard that's also used in React to specify layout. You can think of it as something very similar to UI Stack View, which Apple released with iOS 9. So you can build views as stacks of other views. And you can specify some alignment options and justification and the space between them. And you build more complex views by composing stacks of stacks. So you have composition rather than inheritance. That's CK stack layout. So you build your component tree. Each component is rendered as a stack or some other layout of subcomponents. And then, of course, at some point, you have some kind of leaves. You have primitives like image components or rich text components. So this is what an image component might look like. It takes an image as state, and it has a UI image view as its backing view. And you apply the state by calling the specified selector on the view. But you would never call the selector manually. Instead, you just declare it here. And the framework will detect when the actual image for a UI image view changes and when it needs to call this selector to apply the new state. The framework detects when the state changes. So ComponentKit is declarative. You simply declare components as stacks of subcomponents. You specify the way they are stacked. You never write anything like sizelet views or layout subviews. You focus on what rather than how. It's also functional. You have a one-way data flow from immutable models to immutable components. The infrastructure will call this method. It will build a component hierarchy from it. And then from that description, it will build a view hierarchy. And when something changes, it will rebuild the component tree, run a view diffing algorithm to detect the actual changes, and it will apply those actual changes to your views. Most of this also runs on the background thread. Components can be backed by views, but they are not views. You can build a component tree on a background thread. You can run a view diffing algorithm on a background thread. It's only when you apply the actual view property changes that you need to run on the main thread. So this can be very efficient. And it's composable. You really never subclass components. Instead, you just ensure that subcomponents are truly reusable, composable, and that you can compose them in arbitrary ways using a stack layout or another kind of layout. Now you've noticed that this was not pure Objective-C code. We're using Objective-C++ for this. We don't do this to make our lives any harder. We do have a few reasons for this. One of them is efficiency. Like I said, we need this to be efficient. This powers Newsfeed in our main app. There's a lot of stuff going on there. We need good scrolling performance, even on older devices. That's a challenge. So we need this to be really efficient. What C++ gives us are basically stack allocations. So when we build a component tree, when we run a view diffing algorithm, we are creating a lot of temporary view model structures. With C++, we can allocate them on the stack. Because there are a lot of them, it makes a difference. Type safety means that we are using STL containers rather than Objective-C containers. When we put something in there, when we get something out there, we know the type. We can be sure about it. Syntax was a reason. Basically, C++ lets you do aggregate initialization. So that means when you initialize a structure, you can only specify the fields you care about. For instance, when we initialize a stack layout, we specified the orientation, vertical. But we didn't specify any justification or alignment options because we didn't care about those. We just wanted defaults. So aggregate initialization lets you have a very terse syntax, which is still type safe. And it makes it easier to write these component hierarchies. Nil safety means that Objective-C structures, containers, they don't freak out when you try to insert nil. So for instance, if you have an article component, there might be a specific article that doesn't have a footer component. So the render function for that footer component might return nil, but the rest of the component tree will just behave properly. Okay, so this is component kit, and then we have this other thing, which is called React Native. We released this as open source for iOS in January this year, and I think we released it for Android just a month ago. So React Native is a much more direct port of React. Component kit was heavily inspired by React, but React Native is really a port of React. So you write your code in JavaScript. You have the same JavaScript front end. You have the view diffing algorithm, which runs in JavaScript. The only thing that's different are the virtual DOM elements. So instead of those, you have different kind of leaves, and the leaves in React Native map to native UI views. And that's important. So in the end, you get native UI views. We are not faking anything. We are not using web views or anything like that. If you look at the apps that are powered by React Native, the Groups app, the Ads Manager app, these feel like native apps. In a sense, they are native apps because they have native UI views. So there are lots of primitives you can use directly from JavaScript. You can use things like map views, date pickers. You can use things like core location. All of that stuff is bridged to JavaScript. You can bridge your own code that you might have to JavaScript. You can send events in both directions over the bridge. So what does this look like? Well, it looks a lot more like web code. It's very similar to React. So properties are passed in from above. And you have components which have a render function, and you can use either JavaScript or JSX, which is the blue stuff you see here, to build your component tree. And you can use things like style sheets. But eventually, these are mapped to native UI views. Style sheet properties are mapped to properties on those UI views. So why do we need this? Especially if we already have something like Component Kit. Why do we need React Native? Well, Component Kit gives you the same benefits that React gives you on the web, but on iOS. React Native gives you those same benefits that React gives you on the web on iOS. But React Native gives you some additional benefits that are taken for granted on the web. Things like instant reload. You modify some JavaScript code, you hit refresh in your iPhone simulator, and you can immediately see your changes. You don't need to compile or link. Something like this is taken for granted on the web, but it's pretty cool if you can do it on iOS. And you can go further. Rather than skipping compilation or linking, you can even skip App Store review. You can download code remotely and run it. That's taken for granted on the web, right? You just push your changes to your server. It's pretty cool if you can do it on iOS. And Apple even specifically allows this. If you look at the guidelines, they allow you to download JavaScript code and run it, as long as it's for bug fixes and small features. They probably won't allow it if you just download an entirely different app, obviously. And then there's the potential for code sharing. Now, we've always been very clear about this. We don't consider React Native anything like write once, run everywhere. You still need to write your native apps separately. What you can do is reuse the paradigms you use for web development. We like to think of it as learn once, write everywhere. And there is the potential for code sharing. And we have a cool example of this. We have our Ads Manager team, which was a team of web developers. So they didn't have any native development experience. But they wanted to release an iOS app for their product. So they decided to give this React Native thing a try. And they had estimated that it would take them about 18 months to release an entire iOS app. But using React Native, it only took them 5 months because they could reuse a lot of the paradigms. They could basically use the same kind of development they use on the web. And after that, they also wanted to release an Android app. It only took them 3 additional months to do that, even though they had no prior experience with Android or iOS. And I think they reused something like 85% of their code. So even though it's not write once, run everywhere, there are obvious benefits. There is potential for code sharing, and it's pretty cool. So what's the price you pay for this abstraction? Well, it's this ugly thing, right? So I know a lot of iOS developers are not crazy about JavaScript. Question is, why don't you like JavaScript? Maybe you just think it's a terrible language. It doesn't even have things like static type checking. But at Facebook, we use Flow, which is a set of language extensions, which adds things like static type annotations. It adds a lot of other cool stuff, things like tuples, maybe types, union types. A lot of the cool stuff that you see in Swift 2 these days. Maybe you don't like JavaScript because it's interpreted, but of course that allows you to do things like instant reload, download, remote code downloads. That's pretty cool. That's worth something. Maybe you don't like JavaScript because of performance issues, garbage collection, all that stuff. But on iOS, JavaScript runs on a dedicated thread. That means whatever you do in JavaScript cannot stall your main thread. If your entire app runs in JavaScript, your entire app runs off your main thread. It's actually pretty cool runtime if you think about it. So which one should you use? Of course, it depends on your context. ComponentKit is very much optimized for apps that have a lot of collection views or table views. Apps that have some kind of feed, like Facebook, like a lot of other apps. If you ever struggled with things like height for row, dynamic row heights, cell reuse, all that stuff, this is where ComponentKit really shines. It abstracts all of that stuff away from you. And of course, React Native has these additional benefits that we talked about. They may or may not be important to you. In general, React Native is a bit further away from the metal. And the reason is you need to bridge native code. If Apple releases some kind of new UI view today, you cannot immediately use it in JavaScript. It needs to be bridged first. In ComponentKit, you could use it today because a component could have any kind of UI view as its backing view. Maybe you want to use Swift. In that case, today React Native would be the better option because you could bridge Swift code to JavaScript, but you cannot combine Swift with Objective-C++ the way we use it in ComponentKit. Maybe you really hate C++. Maybe you really, really hate JavaScript. It all depends. Maybe you have some kind of app that is very heavily gesture-driven and has a lot of very complex, rich animations. In that case, you might want to consider taking a look at Async Display Kit, which is another UI kit framework we developed. And this framework specifically targets this use case. Lots of animation, lots of complicated gestures. Or maybe you conclude that none of these frameworks are good for you. And you may be right. It all depends on your context. However, we do appear to be in this state of statelessness. A lot of exciting things going on. If you are still writing classic stateful UI, height for row, size that fits, layout subviews, you just might be missing out on some of the fun. But of course, it's up to you. That's all I got, really. So if you have any questions, I would be happy to try and answer them.
So if you have any questions, I can give you the mic.
Hi, interesting talk. Is there any tooling support, especially for editing JavaScript or this mix of JavaScript and different languages within Facebook?
Could you repeat, please?
Is there anything tooling support-wise for editing those kinds of mixed code, JavaScript, native code, stuff like that?
Yeah, so if you're going to do React Native, you probably won't be writing your JavaScript code in Xcode, but you also don't have to. I mean, basically what you would do is you would build your app once with Xcode, and then you could use any kind of editor you want to use for JavaScript, because you don't need to compile a link again. So you could just refresh. You modify the source code, and if you refresh in the iPhone simulator, it will just apply those changes.
Okay.
One question, but this rendering that you have with Component Kit and React Native, what does it mean really? There is when in the rendering state, every view is stripped from the from the window and is rendered again.
Yeah.
On the view are changed in place.
Yeah. So that's where the view diffing algorithm comes in place. So conceptually, it's reflown. That's what you reason about. But the library will actually, in the background, it will build a new component tree, but it will not build a new view tree. It will compare the component tree before and after your changes. And it will detect the actual changes. So it might see, okay, the only thing that changed is this label over here. And then it will call, it will apply the text modification on that specific label. So that's what we try to avoid. We don't want to throw away any views. We will detect any changes to the views. But you don't need to reason about those changes. The framework will do that for you. Because it's easier to reason about what would happen if I would reflow this entire UI.
Hi, you mentioned one data flow at the beginning, and on the web we have abstractions. Apart from the UI layer, we have abstractions like Flux or Relay or all this kind of stuff. Can they be used off the shelf for React Native development, or do you have any other abstractions that you use on Component Kit and stuff like that?
We do have other abstractions that we use on iOS. I think eventually the goal is with React Native to be able to reuse a lot more of that stuff. Because it's all JavaScript, it becomes a lot easier to reuse it. But when you use Component Kit, we have some other abstractions. They are not all open source because, either we're still working on it or it's too much dependent on our specific network stack or anything like that. But we do have some abstractions like that. So I talked about these immutable models that we're using. That's one framework, for instance. So we are not using core data, we're using immutable mem models.
Thank you.
So today, we are mostly using Component Kit in the main Facebook app. We have some other apps that are using React Native. We are looking at integrating React Native in the main app. But today, it's mostly Component Kit. It's also just historically, so Component Kit was first before we even tried React Native. So today, a lot of it is using Component Kit.
Hi. If you're using a Component Kit to the main application on Facebook, how do you handle basic animations on newsfeed?
Yeah, so Component Kit has some support for animation. So there are some methods that you can. So here I've shown a very basic component. Ideally, you want these pure render functions. There are some hooks that we have to allow simple animation. When you want very complex animation, like I said, today async display kit might be a better option, but we do allow animation in Component Kit. Basically, there are some hooks that will be called. So the framework will tell you like, okay, I have this state and I'm now moving to this state. I will update this component. Is there any animation you want to run to go from this state to the other state?
Hi. How do you handle this list or scrolling, like table views, collection views in Component Kit or?
Right. So most of that is covered by the framework again. So like I said, you don't really need to worry about cell reuse or anything like that. The framework will deal with all of that. You just specify basically if I have a model, what does it look like? What does the UI look like? And yeah, I'm not didn't go into this too much, but like I said, ComponentKit really focuses on collection views. So basically what you do is you hook up a collection view to a ComponentKit data source. And that data source will ask you for each model, like what is the component tree for this model? And then it will call this kind of method. So you say, okay, for this model, I want this kind of component. But again, you don't need to worry about when this will be called exactly, or when views will be recycled. That all happens by the framework. That all happens automatically. But we do have some extra infrastructure to deal with collection views specifically.
Okay, so if there are not any other questions, yes. Oh, okay, right there.
Hi, so how are you propagating user events through the ComponentKit tree? For example, when someone types like button on a story, do you use responder chain or something like that?
Yes, there is a kind of responder chain or something very closely to it. So basically, a component could have a component controller as well. And then we do have a chain where events go from a component to the parent component, and they can basically be intercepted at any point in a component tree. So indeed, yeah, we have something that mimics that, but it's on the component level rather than on the view level.
Okay, thanks.
Hello. What about memory leaks, memory consumption, and overall debugging? Because if you get a crash in some like Crashlytics or anything else, what do you see there?
Right. So I think in general, something like ComponentKit, it's easier to debug than something like AutoLayout. But you're right. Of course, whenever you use a framework, whenever you introduce an additional abstraction, there's a chance. I mean, you are complicating your stack trace, right? I mean, there's a chance that something goes wrong in the stack, and you run into it crashes at some point in your infrastructure, and you will always be a bit further away from the metal with every abstraction you introduce. So it may complicate that. But in general, I think this is not really an issue for us. So when things go wrong, of course, the advantage is if you really have bugs in your framework, you only need to fix them once, right? I mean, so it pays off to invest a bit more time there, so you make sure that your infrastructure is stable. And then all the clients of this abstraction don't run into those bugs. So that's the advantage you get. When you do run into some bug, yeah, it can be a bit harder because it might be a bug in the framework, and you might not be working on that framework yourself. But I think that's the price you always pay whenever you use any kind of abstraction.
We have time for last question, I think.
Hi. Talking about code sharing, if you have to build an app that runs on iOS and iPhone, so I'm thinking, about React Native, how much do you think is going to be, the code sharing there in terms of percentage, if you have an idea of that?
Right. So I only have a few specific examples. It's all pretty new technology. What we do have is this Ads Manager app. I know they were able to reuse 85% of their code between iOS and Android. So that's really significant. Yeah.
Thanks.
Sure.
Okay, so thank you, Hans.